The previous talk was organized with a nice, in one sense, beginning and ending, because it's a success story in creationism. You got enough of a time element here, at least 16 years has elapsed, that you can actually see the beginning to something along the more developed side of a theory. What I want to present now is much less structured, because we're not as far along in that process. No less exciting. In fact, I would argue in many ways much more exciting. But it has to do with one of my favorite periods in Earth history. Actually, I have several. This is one. Arphaxad was, you all know, a person who was born 2 years after the flood and lived for several hundred years after the flood. So he's the son of Shem. So here's a guy that was born just 2 years after the flood of Noah and lived for hundreds of years, overlapping with the beginning of the life of Abraham. That was an extraordinarily exciting period in Earth history. And so I call that period of his life the Arphaxadian epoch. Okay, it's just really cool. And I just wish I was Arphaxad. I mean, of course, I'd be dead, but I don't remember offhand. It's 400 and something, I don't know, something like that. But the really interesting period, geologically, biologically, and I suspect in about every other way we can ultimately study it. So what I want to do is just give you first a geological context, and then focus on biology in the second half of the talk. This slide, to some extent, even ignoring the geologic intensity, but just the curve there, pretty much summarizes, as in the simplest way I know, what happens after the flood. Whatever is occurring in the flood, however you describe it, is big. And then as time goes on after the flood, things settle down. The biggest catastrophes in Earth history, the biggest earthquakes, the biggest volcanoes, the warmest period in Earth history, the wettest period in Earth history. I think that's one of the most profound things that and so on. I mean, and then the Earth, basically the story of the Arphaxadian epoch is the Earth recovering, and we're still in the recovery period. I would argue that all of the earthquakes and all of the volcanoes today are still leftover remnants of the flood itself. The huge volcanoes of the flood reduced to supervolcanoes following the flood, to the small, teeny-weeny, insignificant volcanoes we have today. The huge earthquakes of global earthquakes that we have in the flood, that are moving at the beginning of the flood, pieces of boulders that are 4 to 5 miles in diameter. The evidence we have of that at the beginning of the flood, to superquakes following the flood, to the teeny-weeny little quakes that only kill 20,000 people at a time in the present, and so on. This is the story of the Arphaxadian epoch, put simply. So we have, for example, the evidence of the volcanism. We have volcanic ash. It's the amount of volcanic ash that we have, for example, in the western United States, is incomprehensible. The Painted Desert, the Shinle Formation, is 98% volcanic ash. There's 1,000 feet of this stuff over most of the western United States. You see, it's a lot of volcanic ash. There's a lot. I don't know. And then when you get into that's during the flood. When you get into the post-flood period, you have these big volcanoes. These supervolcanoes, like the volcanoes in Yellowstone National Park that left volcanic ash over all the western United States. 5, 6, 7,000 cubic kilometers of rock pulverized. So imagine a block of rock, 6 miles by 6 miles by 6 miles, pulverized into volcanic ash and tossed over the western United States. That's what Yellowstone did more than once. It would suggest that if that volcano went off today, with that kind of intensity, there would be no survivors west of the Mississippi River. No human survivors. And there would probably be no animal survivors with smaller, any larger than pocket gophers over that same region. I mean, this is huge. These are called, even in the secular world, supervolcanoes. And they reduce in strength and size and danger to Mount St. Helens, that little red dot there. Mount St. Helens pulverized 1 cubic kilometer of rock, a small, insignificant amount of... It destroyed 256 square miles of land in 6 minutes, but it was teeny. I mean, teeny. Even Krakatoa, which is, people will say, "Whoa, big stuff." It was like 13 cubic kilometers. It's nothing compared to these things that are thousands of cubic kilometers in size. So the volcanic intensity is dropping. Earthquakes are dropping in intensity. I've done a bunch of work out in the Kingston Range in California, sitting right on the California-Nevada border. And it is an isolated mountain range. Looking at it from above, it's almost circular in cross-section. It's centered on the highest peak is called Kingston Peak, thus it's called Kingston Range. And there's a pluton, a granite peak, big piece of granite in the middle, and then all of this stuff has fallen off the sides of it. And we've discovered, actually, in doing seismic work, that this mountain has no root, which is a phenomenal thing. Most people don't understand that mountains have roots. Mountains have to have roots. Most people think you can just, if you take a big boulder, let's say you got a boulder that's a mile in diameter and you're able to make it and you just set it on the ground, that a million years from now it's still going to be sitting on the ground. A boulder which has, let's say for the sake of argument, the same composition as the rock underneath it will sink into the earth until it becomes flat. It's just the way, it's like you put ice cubes into, you put water into a bowl of water, and you don't get a pile of water in the middle where you put the water.